All right, so let's roll with it. We're going to start off with System Sprawl. This, again, we're still in Domain 1. And Domain, I've said it at least 4 or 5 times. Domain 1 is huge. There's a lot of stuff going on in Domain 1. Domain 1 is about a quarter of the exam. It's going to be things you need to know. This is foundational stuff. So Domain 1 and Domain 2 are huge. Between those two domains, it's about half of the exam. So this one we're talking about 1.6, part of 1.6, System Sprawl, and Undocumented Assets. This is stuff that'll get you, right? So undocumented assets, you have to make sure that hardware and software assets are accounted for. We know that within security, assets are the thing we're protecting, right? In addition to hardware and software assets, remember that data and information is an asset as well. Hardware and software assets are the number 1 and number 2 controls in the SANS or the CIS top 20. Number 1, keep track of your hardware. Number 2, keep track of your software. If you don't know what hardware you have, if you don't know where it's at, if you don't know how it's configured or how it's connected to your network, there's no way you're going to protect it. There's no way you're going to know when it's been attacked, right? Correct documentation is critical. And really, in today's world, you have to have some type of database that keeps track of your equipment if you're an even moderate-sized organization. So, if you can't do this, then you're not going to be able to manage the security in your organization. This is essential to patching, traffic flow analysis, data management, data protection, and a number of other security principles that are wrapped around this. And it goes back to, if you don't know what you have, how in the world are you going to protect it? Tied to this is System Sprawl. And this is just, we keep adding to our environment. We expand the number of systems over time. As we move forward in technology, technology requires new assets. Old assets aren't recovered or decommissioned. This can be incredibly difficult in virtual environments where a keyboard click or a mouse click can create a new server, a group of servers, or an entire environment. We can spin these things up in something like AWS or Google Cloud or Azure, and they may sit out there. We may go do a little bit of testing, spin up 10 or 20 or 50 servers, go to do something and forget that those servers are out there running. Now we're paying for them. Now there's vulnerable systems out there. Depending how they're configured, they may be a giant gateway into your environment. Documentation helps alleviate this. Following processes helps alleviate this. Architectural planning and review is critical to this. Change control and change management is critical. When we talk about System Sprawl, it's, you start with a number of servers or systems. Let's say you start with 100 servers, and a new project comes along and you add 10, and another project comes along and you add 10. And you do this over and over and over again. And pretty soon you've got 200 or 300 servers. Some of those old ones are still out there running that didn't get decommissioned. We moved on to the new thing, we didn't think about it, or it was extra work that we didn't think about. So we're sprawling. We don't have correct documentation on these things. We don't clean up the old systems. Remember, decommissioning old systems is a process unto itself. So we have to go through, make sure we take care of what's going on with the data of that old system. Can we delete it? Do we have to retain it? What's going on with the hardware and software? Can we reuse licenses? Can we recover hardware and use it for something else? How do we get rid of it? All that stuff. System Sprawl is just, we keep expanding our IT infrastructure and we don't ever clean it up. So that, in a nutshell, is what we're talking about when we talk about System Sprawl and undocumented assets. We have to document. It's something no one really likes to do. Folks really, we talk about documentation. We talk about keeping things updated and doing the paperwork. It's not the fun stuff. It's not configuring servers. It's not things most people want to do, right? Change gears here. Same thing. We're still in 1.6, and we're going to talk about architectural design and weaknesses. So this is really the high-level view of our organization. We should have an architect. We should have an IT architect that's building the IT environment, and we should also have a security architect that's making sure that security is working across that entire infrastructure. So flaws in architecture of the organizational IT design and flaws in architecture of the security design lead to architectural and design weaknesses. Because this is at the enterprise level, we're talking about devices and systems and configurations that cost tens or hundreds of thousands of dollars, sometimes in the millions of dollars, to change if we don't get it right. That's why architectural planning and design planning is so important. It's costly and difficult to correct once it's in place. It's often fully requiring a redesign of the environment to fix this. So some things we see over and over again in the real world, so-called real world, right? In people that are practitioners of security is flat networking environments, right? Where everything's flat, a big flat network, one big giant network where if an attacker gets on one machine, they could easily go across the entire network, pivot, and attack any other machine. So we want to compartment. We want to have stratification. We want to have different environmental levels of our network. We want to have separation of our network, right? Big flat networks used to be a thing people did. We don't want to do that. IT systems incompatible with security systems. So we think about security systems. Security is going to build an environment that supports IT. Security will have things like logging and monitoring, SIEM, antivirus, patching software. All these things are going to support the IT infrastructure. If IT builds systems, for example, maybe they're not compatible with the logging and monitoring system, they're not going to be compatible with the environmental SIEM, security event manager, and that means we're going to have a problem with our architecture. Something's going to have to give. Depending on how much money has been spent on those two components, it may be security that has to change, or maybe the IT folks have to change. But it's a design weakness. We didn't think about that when we went to build the IT infrastructure, or we didn't think about it when we built the security infrastructure. Failure to plan for the future is another problem. If the security and the IT architecture leadership doesn't keep track of where the business wants to go, it's easy for the business to point to something like, we want to go to cloud in the next 2 to 3 years. IT and security need to be able to adjust to that, be able to start moving over. There's different tools that take care of security in the cloud than take care of security on premise. And we have to be able to plan for that. So architecture and design, we have to think about not only what does architecture look like today, how does it all work, how does it all connect, what are some flaws with it, but how are we planning for the future? How are we keeping track of what the business wants to do? And then one thing I found, and this is not going to be testable. This is not something that is on Security Plus. This is something outside of Security Plus. When I was getting ready for this, I found the software blog that talks about common architecture weakness enumeration. And this is honestly a little more focused at software, but it certainly can be used in your infrastructure planning, right? So there's 3 big weaknesses that this common architecture weakness enumeration calls out. Flaws of omission, and this is such design flaws resulting from ignoring security requirements or potential threats, such as flaws to identify decisions that were never made, right? So we go through and we see things like, we don't ever think the hacker's going to get inside our environment, so we maybe store passwords in plain text on computers, desktops. We don't think that's a big deal because we probably, the attackers never get inside, so that's a flaw of omission. We don't ever think there. Flaw of commission is flaws that refer to the design decisions made, which could lead to undesirable consequences. We pick a certain program that's going to provide protection for malware protection. And it also maybe is a tool that is found later, or maybe found before we picked it, to also be providing a feed of intelligence back to a nation state or something like that. And then flaw of realization, the design decision is correct, but the implementation suffers from mistakes. So it's a good product, but we implemented it poorly. So 3 things that the common architecture weakness enumeration, if you ever hear that, it's one of the things that's kind of on the fringe of this architecture and design. I really hadn't heard much about it, so I think it's good to share with you. Maybe something you can use in your daily life. Talk about this: flaws of omission, flaws of commission, and flaws of realization. 3 different ways we can have weaknesses in our architecture that can probably come back to haunt us a little bit. So that's the rundown. That's your coverage of 2 more topics in the Security Plus Domain 1. As always, I'm Jim with Cyber-Recon. Love to see your comments. Comment below. I'd love to hear what you got to say. Have you seen any problems with architecture in the past? Have you experienced any system sprawl problems? What's that lead to? What can you tell all of us about? We'd love you to hit the bell so you'll be notified when new content comes out. Subscribe. Obviously share with your friends. And obviously like. Well, those all help us. Anyways, I will see you next time. And be safe out there.